The next application of total internal reflection is total reflecting prism. Total reflecting prism. So when we take the prism like this, so this is the shape of the prism, means when the light enters in this manner, what will happen? This will be reflected. So here what will happen? The light enters from denser medium to rarer medium. This is a glass, this is a air medium, this is a glass medium. Then what will happen? Denser medium to rarer medium, light will hit. Here at this point, the angle of incidence is greater than the critical angle. Then what will happen? Total internal reflection take place. Similarly, at the same manner, when the light hits in this, here the light will be reflected. So this is what is that? Reflecting. So this is a deviate of a ray to 90 degree. When the object is in this height, when the object height is like this, means the image will be formed in this manner. So this is a object, this is a image, so 90 degree rotated. Then next one is when the prism is taking, when the prism is like this, means when the light enters here also the total internal reflection will take place. Total internal reflection will take place. What will happen? Here the total internal reflection, when the light enters from this medium to denser medium to rarer medium, again here the denser medium to rarer medium, it will be reflected back. So when the light enters here and it will be reflected back. Again the second ray will be come and hit, reflected back and comes here. So this is a, what is that? This is a 180 degree phase. So when the object height is like this, then the image will be upside down. So this is a 90 degree deviation. This is a 180 degree deviation. This is an object. This is a image. This is an object. This is an image. There is another reflecting prism. The prism is the device used to refract the light. It will disperse the light. Everything we know that. But when the angle of incidence is greater than the critical angle, because it obeys a condition for total internal reflection. The light enters from denser medium to rarer medium. So the angle of incidence is greater than the critical angle. What will happen? Total internal reflection take place. Even if you take the prism like this. So what will happen? When the light enters from rarer medium to denser medium, it will be refracted. It will be refracted. In this case, here the denser medium to rarer medium. So here the total internal reflection condition obeys, means it will be again reflected back to the same medium. Here the refraction will take place. So this is a refraction will take place. So here also, what is that condition? The invert image without deviation. The image object will be like this, but the image will be inverted 180 degree, but this is an image. Okay. This is an image. So object is inverted, but the light is not deviated. Here also the light is not. It will be comes in the opposite direction. So these are all the applications of total internal reflection in total reflecting prisms. Optical fiber. So optical fiber is a glass material which is made up of core. It will be has a core and cladding. Both the core and cladding are made up of the same material, but the refractive indexes are differ. Here the refractive index of the core is greater than the refractive index of the core is greater than refractive index of the cladding. That is, the core is a denser medium, cladding is a rarer medium. Keep in your mind. Okay. So when the light enters from air medium to core medium. So core air medium means it is a rarer medium. The refractive index is N0. When the light enters from air medium to core medium, this is the angle of incidence. What will happen? Rarer to denser medium, the light, this is a normal line. The light will move towards the normal. This is a refracted ray. So here this is a interface. So the light incident on this interface with an angle of incidence is greater than critical angle. Here the light travels from denser medium to rarer medium because the core is a denser medium, cladding is a rarer medium. So this is a denser medium, this is a rarer medium. So when the light enters from denser to rarer medium, if the angle of incidence is greater than the critical angle, what will happen? Light will be reflected back to the same medium. Again it will come and hit here. Here also the light will travel from denser to rarer medium. If the angle of incidence is greater than the critical angle, it will be again reflected back to the same medium. So that is the light will be propagated through the optical fiber by using total internal reflection. Again I will explain you. We have to select the certain angle of incidence so as the refracted ray from air to core medium will be hit on the core to cladding interface at an angle of incidence greater than critical angle. Hence, the light travels from denser to rarer medium. Angle of incidence is greater than critical angle. So, the light will be reflected back to the same medium. So, total internal reflection takes place. At this interface also, light travels from denser to rarer medium. The angle of incidence is greater than critical angle. It will be reflected. So, in each and every point, so what will happen? The total internal reflection must be obeyed. So, how it is possible, sir? We have to do like that because the manufacturing design of the core and the cladding refractive indexes and the angle, this angle is called acceptance angle of the fiber. This is the acceptance angle. If the light will within this area only, we have to send the light into the fiber. If the angle of incidence is greater than this acceptance angle, the total internal reflection condition not obeyed. So that is the condition for optical fiber. Where the optical fibers are used, so optical fibers are used in medical purpose examination of the inner organs of the human beings. The endoscopy, when you are going to ENT doctor, the doctor will send a certain tube-like structure, rod-like structure into the ear or nose. He is able to see the inner organ through the TV. So that is a endoscopy, that is works on the principle of total internal reflection. That LED light will travels through the optical fiber in the doctor's hand. That fiber wire only take the signal to the TV and the TV shows the picture. So even in the telecommunications and the photometric sensors, these optical fibers are used. So very simple. This is an application of optical fiber, how the optical fiber works on the principle of total internal reflection.